one. Liftoff. We have a liftoff.
Sure. The Hubble Space Telescope sees in colors of light that are very much like our own eyes. We call it the visible spectrum. That's the colors of the rainbow. Now, Hubble can do a little bit better than that in that it can see ultraviolet light. So if you go through the rainbow and you start with red and green and you get to blue and violet, light just keeps going. And ultraviolet light is shorter wavelength light than violet. And if you keep going beyond that, you get to X-rays and then gamma rays. Our eyes can't see those colors. If you go towards the red, you get to red and then infrared, and we don't see infrared either. Some animals can see infrared light, just not humans. And those animals are typically adapted for nighttime. In fact, you can keep going even longer, and you can get not just the near infrared, but to mid infrared. And then you go beyond that and you start getting into radio waves. So the James Webb Space Telescope was designed to see infrared light. And one way to think about infrared light is it's longer wavelength light than visible light, but also it's kind of the wavelength of seeing heat. Now, all light is related to the temperature of the object that we're looking at. But if you think about something that's the pictures that you've seen of maybe an animal or maybe of a person that shows that, on a human, the nose is warm, but if you look at a dog, the nose is cold. Well, in those weird fuzzy pictures, a human's nose would be very bright and a dog's nose would be very dim. And that's because something that's warm emits more infrared light. Now, why would we want a telescope that looks at infrared light? And there's lots and lots of reasons. The main reason for the James Webb Space Telescope is that it wanted to look at the very early universe. And in the very early universe, there were a lot of super hot stars, and they were emitting visible and ultraviolet light. And so you scratch your head and you say, well, I thought you said James Webb was supposed to look at those early objects, the first stars, the first galaxies, and they're emitting ultraviolet light. But the universe is expanding, and that light is going to take 13 billion years to get to us. When we see it today, but it was emitted from the galaxy billions of years ago. And as the universe expands, it stretches out that ultraviolet light so that by the time it gets to us, it's now in the infrared. And Hubble can't see that light because it's just not built for it. So we had to build the James Webb to see that kind of light. Now, the other interesting thing about that infrared light is it's also the color of light that many molecules emit. So the ultraviolet light that Hubble sees, or the visible light, is caused by electrons in an atom making a transition from one orbital down to another and emitting a hot photon, a particle of light in the ultraviolet or in the blue. For molecules, they have much less energy than those electrons and atoms. And sometimes molecules are spinning and they change their speed a little bit and they give off a photon of light in the infrared. And the specific color of that infrared photon tells us what kind of molecule it is. So we'll be able to study in molecular clouds of gas and dust in our galaxy or around a planet. We'll be able to tell what kind of molecules there are. I'm specifically interested, personally, in looking at the moon of Jupiter called Europa to see if we see any molecules in water coming off of the surface of Europa that might tell us whether there could be life under that ice. And so that probing ability of James Webb is really what's going to make it an extremely exciting observatory, not only telling us what the first stars and galaxies were like, but also how gas and dust is swirling around inside of other galaxies, in our own galaxy, stars and planets in our own galaxy, and looking at the atmospheres of planets around nearby stars. Really, it's going to be incredible.
5, 4, 3, 2, 1. 0. All engine running. Liftoff. We have a liftoff.
The real power of astronomy right now is that we have lots of different observatories. The James Webb Observatory will be in the infrared. The Hubble Observatory is in the visible light, the colors of the rainbow like our eyes. And on the ground, we have radio telescopes and some really big optical telescopes, and they all work together. Sometimes a ground-based telescope will discover something. Maybe it's a supernova, a star that exploded. And then we can turn the Hubble and what will be the James Webb, we could turn that and study it in more detail than we could on the ground. Or the Transiting Exoplanet Survey Satellite TESS will discover a planet around a nearby star, and we can use either Hubble or the James Webb Space Telescope or a ground-based telescope then to zoom in and study that in more detail. And in particular, the James Webb Space Telescope will be a great telescope to look at these planets orbiting nearby stars and to interrogate, to ask questions about what's the atmosphere made out of. And I'm hoping that maybe we discover a planet that might be kind of like Earth. That it would be pretty exciting.